Hi guys, good morning. Good morning and welcome to my first physics class in a virtual mode. Today's topic is about the first law of thermodynamics. First of all, I think I already gave you the introduction of the topic, and we already stated that there are some special processes for the thermodynamics. First law, that we have isovolumetric, isothermal, adiabatic, and isolated system. Now that chart, you can see it is in the page 340. It's right there. Now, the first law of thermodynamics states that the change in the system's internal energy, we're going to call it as delta U, or just U. Okay, Q is for heat and W is for work. So the first law of thermodynamics states that the change in the system's internal energy is equal to heat minus the energy transferred to or from the system as work. So this is the main equation that we're going to use according to the type of problem that we have. Now, just a reminder, isovolumetric, it has a condition, no work is done by the system. And isothermal means that there's no change in temperature, therefore delta T is 0, therefore the internal energy will be 0 and heat will be equal to work. And adiabatic, no change in heat. That means that heat will be 0 and delta U will be, okay, these are conditions, very special conditions that I already told you about. It depends on the word problem. And the last one means that there's no change in the system's internal energy because no energy is transferred as heat, so heat will be 0. As you can see it over there, here, Q equals 0. And no work is done on or by the system, so W is 0. So delta U will also be 0 because the main equation says delta U equals Q minus W. So if Q is 0 and W is 0, will be delta U equals 0. Okay, that's an isolated system. And when are you going to know if you're going to use one of these processes? According to the word problem. Now, let's take a look at the first example. This sample problem, you can find it in page 341. So, I will read the problem, but I know that you can actually read it from here. It says, a total of 135 joules of work is done on a gaseous refrigerant as it undergoes compression. If the internal energy of the gas, sorry, I have a piece of eraser over there. If the internal energy of the gas increases by 114 joules during the process, what is the total amount of energy transferred as heat? Has energy been added or removed from the refrigerant as heat? So we have to answer. As you can see, we have one question over here and the other question right over here. So first of all, as I've been telling you all this time, it's very important that we first take out the givens. Now the first given is the work over here, because it says a total of 135 joules of work. So now you know work is going to be the first given, and it's 135 joules. And it says it's done, remember that keywords are very important. That work is done how? On or by the gas. It says, the problem says the work is being done on the gaseous refrigerant. Therefore, as it is on, you know that it's going into compression. Why is this so important? Because if you remember, when we learned the topic about work done on or by the gas, that tells us the symbol of the work. As it is on the gas and it is compression, the symbol of this work will be negative. Remember this. This is very important. Now, The second given is if the internal energy. How do we state or how do we name internal energy? You know, work is W. Heat is going to be Q. Internal energy is going to be U. So if the internal energy increases by 114 joules, the problem is giving me the second information, valuable information, that is internal energy equals 114 joules. Now, what is the total amount of energy transferred as heat? The problem asks me to find heat. How do we write heat? With a Q. So Q is going to be unknown. And the second question is, has energy been added or removed from the system? So, which one is going to tell me if the energy is being added or removed? If, for example, when you isolate Q and the symbol gives you positive, we can say that Q is added to the system. Now, if it's negative, we're going to see that is removed. Now, what is the first equation that we have to use for thermodynamics? The first law of thermodynamics is the one that we already heard. Not heard, well, you heard, but you also saw it. Is, I'm going to write it in blue because that's how you're going to write the equation, okay? The first law of thermodynamics. Now, this is the procedure. You know, the first law is delta U equals Q minus W. That is the first law of thermodynamics, okay? First law. Now, we need to isolate which one? We must isolate Q. So work is being subtracted to Q. So we need to send work to this side of the equation, as it was subtracting, and the other side will be doing addition. So delta U plus W equals Q. We have our equation already isolated for Q. And then we say Q is going to be equal to delta U plus W. Which one is delta U? From the givens, we know that the internal energy is 114 joules. Plus, now work, W is for work. Work is negative 135 joules because the work is done on the system, so it is negative. So we say plus negative 135 joules. Plus and minus gives you negative, so 114 minus 135 gives you Q equals, you do it with your calculator, of course. I know it's just a little addition and subtraction. So 114 minus 135, negative 21. Joules and joules will give you joules. And this is our final answer. Remember, every time you have an answer, you have to box it. And now, question. You have already your Q. It's not unknown already because you have that is equal negative 21 joules. But now tell me, is the heat added or removed from the system? The symbol is negative, so we can conclude that heat is being removed from the system. So we say energy is removed. And what tells you that? The symbol of heat. Oh, sorry, you can actually see it. But it's right there. Energy is removed because the Q, heat, remember Q stands for heat, is negative 21 joules. Okay, guys, we continue. We're gonna develop sample problem number 2. it says the internal energy of a gas decreases by 500 joules. If the process is adiabatic, how much energy is transferred as heat? How much work is done on or by the gas? We don't know it, so we're going to find out. That's the idea. Now, as I already told you, the thermodynamic processes, the special processes, tells you something very important. This exercise is telling you that this process is adiabatic. So what are you going to do? Remember that I told you before that these processes, you have to learn them. Now, adiabatic process, what is that condition? Remember, that is in page 340, the table. Okay, that condition of an adiabatic process, let me just focus a little bit better. Okay, condition, it's here, the second row, the second column, sorry. Adiabatic says, no energy is transferred as heat. What does it mean? That Q equals 0. So, okay, I'm gonna show you better. Okay, it says, a adiabatic process, the condition is no energy is transferred as heat. And Q, okay, if no energy is transferred as heat, Q is going to be 0. Heat is going to be 0. So the change in internal energy delta U will be equal to the work in negative. So negative W. Now, this is the condition that we have to care about this exercise because it says there is a process, an adiabatic process. Now, from this problem, we have to take the givens. Sorry, it was a little bit blurry, but now it's okay. Now, the internal energy of a gas decreases. This is a very important word, decreases. Decreases, if I tell you about an increase, you're going to think about something positive. If we're talking about decreasing, something that decreases is something that is going downward, for example. So as it is going downward, we need to consider a symbol to be negative. Now, how, with what letter do we state internal energy? Okay, first we have to get the givens. Internal energy is delta U. Delta U, it says, decreases by 500 joules. So, it is 500 joules, right? Just 500 joules. No. It says decreases, therefore the symbol should be negative. If the process is adiabatic, that is a given, the type of process. And what is the condition for adiabatic? That Q is equal 0. Now, how much work is done on or by the gas? We need to find the work. How do we write the work? W is unknown. Now, the first law of thermodynamics, we already wrote it in the exercise before. It says delta U equals Q minus W. If we know that this is an adiabatic process and that Q is equal 0, so basically we now have that the change in the internal energy is going to be negative W. But I'm not looking for the internal energy because I already know that is negative 500 joules. So what am I going to look for? I'm going to look for W. Now this W is negative. In order to become or to turn it positive, the idea is that you guys multiply times negative 1. Remember, this is like an equation, like a mathematical equation. So the idea is that you multiply times negative 1 in both sides of the equation. Okay? Now negative and negative will give you W positive. Negative 1 times delta U is going to be negative delta U. Okay? Now, let's isolate for the work. Just plug in the given. We have this negative here. Delta U is negative 500 joules equals work. Negative and negative makes it positive. 500 joules equals work. This is our final answer. Now, the other question is work done on or by the gas? How is this answer? Positive? Or is it negative? As you can see, negative and negative gives you positive. If it is positive, we can conclude that work, sorry because of that, work is done by the gas. Okay guys, this is everything about the first law of thermodynamics. In the presentation you will have your homework, your assignment. Try to do it. If you have any doubt, you have to send me a message. I'll be available for you. And I hope you are doing okay. Please stay at home. I want to see you when we come back. So if you have any doubt about the topic, you can ask me. Remember to re-watch the video if you still have doubts. Study hard and do your homework.